everybody. Hi. Good morning. I think this will be... We were still working on our slides late yesterday, but we're all set to go. I think this will be my 6th time presenting at RubyConf, 7th time attending. We're going to talk... as we did last year, we decided that we weren't going to do just a general JRuby talk, because most people can find those talks online, find information about us, and it's Ruby that runs on the JVM. It's really not a whole lot that we need to say usually. So we thought we'd do something a little bit different and talk about JRuby combined with a bunch of other JVM languages. And so we have JRuby Polyglot Heaven today.
I think it would be safe to say we stretched ourselves a little bit doing a polyglot talk.
Yes, exactly. We don't actually know any of these other languages all that well. So it'll be interesting once we get to some of the code stuff. But before we get going, we do want to commemorate the fact that this month or next month is basically the 10-year anniversary of the beginning of JRuby. 10 years ago, 2001, Jan Arne Petersen started the first version of JRuby. Here's all of the different JRuby versions we've had over time. 1.6.5, which will probably come out after we do Java 1 next week, will be the 50th official release of JRuby. So it's very exciting that we've been going so strong. So here you go. September 10th, 2001, the initial revision of JRuby was originally committed to the repository, followed the next day by the initial check-in. I'm not exactly sure what the difference between those two were, but it all started at that point. And slowly over time, more and more contributors came, contributors went, and we're here today.
Was the first one the README?
Yes, perhaps it was just the README file or the initial repository. So we've had hundreds of contributors over the years. When I checked earlier this week, we had over 14,500 commits over that amount of time, which is actually very similar to the MRI repository in its entire lifetime. Thousands of users worldwide, many more than we know, lots of interesting ones that we do know. And thank Rubyists, and thank JRubists around the world for helping to make JRuby what it is today. So right now we have JRuby 1.6 is the current version. We've got a 1.6.4 maintenance release. That's the one out right now. We added Ruby 1.9 support, which is in the neighborhood of 80 to 90% of stuff is there. There's more work that we need to do, and we need more tests and more specs. But it's pretty solid, and there are people running with it now.
Just a quick hand. Is anyone using 1.9 in production with JRuby? Oh, we got a few hands.
Anybody running 1.9 production on MRI now? It's getting there.
It's
definitely picking up. Over the past year, it's definitely become much more likely that people are running 1.9. It's still kind of ramping up, though. We added experimental C extension support in this release, thanks to Tim Felgentreff and the Ruby Summer of Code 2010, which was an incredible effort. And actually, a large number of extensions do work. There's some limitations when they run on JRuby, but as a migration strategy, a lot of times you can install those gems and they'll work until you can find a more compatible option. Hundreds of fixes in that release, thousands of commits. It was every big release we have seems to be even bigger than the other one. And I think this 1.6 was actually bigger than 1.4 and 1.5 combined. So there was a tremendous amount of work that went into it. And I mentioned 1.6.4 is the current maintenance release. 1.6.5 comes along soon with some more 1.9 fixes and other stuff. I'll get our plugs out of the way. Engine Yard Cloud now officially supports JRuby. It's not in beta anymore. So if you're familiar with the Engine Yard Cloud, or if you want to be familiar with the Engine Yard Cloud, you can just drop JRuby applications in there with all your Java libraries, with whatever languages and libraries you want to use from the JVM, and it will just run like anything else in the cloud. And you can go to try JRuby at theengineyard.com for the 500 free hours, or check out our blog for more information about it.
Buy it.
Yes, and here's the book. The book also came out this year. We finally got it finished and released it this past winter. I will be tossing a copy into any giveaway that might be done as part of RubyConf today. So hopefully one of you will be able to get a free one. But if not, you can go ahead and pick up the book and let us know what you like and if you'd like to see something new in a second edition.
Okay, so now the talk begins. I don't think any of us would be here if we didn't love Ruby, but I think we all acknowledge that some languages do things better than Ruby for some things, so there's good reasons to use additional languages. And actually, we're already all polyglot programmers to begin with, because you just have to write one web application. You just use a whole plethora of technologies. And the goal of the talk today is to actually show that it's quite easy to use another language from within JRuby. In fact, it's super, super easy to install. This is one of our favorite features as of late. Maven is this really crappy build tool, but it has an incredible number of jars published to a repository. And if you want to install any of the jars from that repository, you just do mvn : and you specify the group ID or the association that published it, and then its artifact ID or the name of the jar.
So pretty much any of the tens of thousands or hundreds of thousands of JVM libraries that are out there are kind of just transparently installable as gems on JRuby.
And there's like 200,000 jars out there. It's like every version of every jar ever released, but how weird is that? If you want to actually go and find one of these libraries, you can go to mvnrepository.com, put in your search string, and then the group ID and artifact ID is just right there. I think this took Charlie about 20 seconds to fill in this table, so it was actually quite easy to find this stuff. And these are going to be the languages that we're going to be talking about today.
As well as Java, obviously.
As well as Java. It's tough to avoid Java in JRuby.
Yeah.
So there are a couple problems with Maven support at the moment. If you wanted to make your own gem and push it to rubygems.org, rubygems.org doesn't allow external dependencies, so we need to fix this. Also, unfortunately, you can't put a Maven dependency in your gem file, so we need some help fixing Bundler to allow this as well. So if this sounds really interesting and fun, please come on and talk to us after the talk, or email us, or send us a carrier pigeon. I don't know. So polyglot programming is quite a bit nicer on the JVM than it is ordinarily, because all these languages are built on top of the same base, or the JVM. They have the same garbage collector, they use the same thread scheduler. Everything gets compiled down to Java bytecode, so if you want to run on OpenBSD Crazy Edition, you don't have to like compile 3 different language runtimes. You just have the jar files and you put them there and they run. The other thing worth mentioning is we're only showing 4 languages, or 5 if you count Java, but there's over 100 languages that people have implemented. Some of them are toys, but there's many other serious languages that are out there as well. I just wanted to underscore the point about having a common base of the JVM, in particular the GC. So here's an example showing C Ruby. Let's say you go and embed J9 through a native C extension, and like any application, it gets reasonably complex. It's been running for a while, and you have a memory leak. Well, you hook up to your memory tools in Ruby, and maybe you find it. But if you don't, then what? Is this memory fragmentation because MRI doesn't have a compacting collector? Is it, in fact, JavaScript? In this scenario, maybe you can hook up to the JavaScript engine and figure it out, and maybe you can't. But it leads a big cloud of mystery that I don't think most developers would actually want.
This is also one of the downsides of C extensions, because C extensions have their own memory management, and they do things their own way. Oftentimes, you can't see where RMagic has managed to stuff that 4 megabytes of memory that is never going to come back. Having it all be on the same runtime and the same object model and the same GC, it's all available, it's all inspectable, everything is there, and you don't have that mystery.
And we even have a term for it, and it is the RMagic problem.
Yes.
If you actually go and run in the JVM, the JavaScript implementation Rhino is based at Java-Lang object, just like JRuby is. It runs in the same collector. Now if you have this memory leak, you can go and hook up to a JVisual VM, inspect the heap, and it'll be really obvious that there's something that's holding on to too much memory in JavaScript.
And for example, if you're using tools that will walk the heap and show which objects are referencing other objects, you'll see Ruby objects that reference JavaScript objects, that reference Scala objects, because it's all just objects in memory.
Parts is parts. A lot of people find that communicating between languages is difficult, And this certainly can be true, and we're going to make some recommendations that will make it a lot simpler on Java. We did actually spend an immense amount of time making Java feel like a first-class citizen from within Ruby, and Charlie's going to be giving a demo of that in a couple of minutes. And Java can call back into Ruby. So we have this nice bidirectional communication with this language. But what if we decided that it was important to support Clojure? We could certainly go through the same amount of work again. But as a language implementer, as more and more people express interest in supporting different languages, this becomes pretty unscalable for us. In fact, it might not even be possible for us because some of these languages' syntaxes are exotic enough that they just wouldn't fit into a Ruby syntax. So they can't really be first-class citizens. However, every language written on top of the JVM wants to be able to use Java libraries so they have good communication with the Java language itself. So what we recommend is using Java as the interchange format for communicating between languages. In particular, we recommend constraining the use of what you pass to Java for this communication to be simple primitive types. There's one odd man out here, and that's object, which you can essentially use as an opaque reference or a pointer. So you could pass a Ruby object to Scala. Scala will never do anything with it except to hand it back to Ruby later to have Ruby do something with it. But basically simple types and maybe one pointer. All these languages also can implement interfaces and call methods on an interface. So what we recommend is doing all communication through an interface, and then this encourages you to create essentially a coarse-grained contract because you're crossing a pretty big barrier going between two languages. So we find this to be a reasonably simple strategy, and you'll be able to manage it better over time because you will have to go through the pain of recompiling an interface every time you want to change it.
Just as in any complex system, you want to treat those different pieces in the different languages as their own components. Define a nice interface in contract and use that as your way to interface rather than doing raw method calls across the boundary all the time from one language to another.
We like beer.
Yes. Does anyone recognize what these are? Yes, yes. They are keg connectors for a tap. All right, so of course we can't talk about integrating with languages in the JVM without at least brushing across Java here. And so really what we're talking about here is that it's the primary JVM language with thousands of libraries. Really, all the libraries are just bytecodes. So when you say that there's a lot of Java libraries, you're really saying there's lots of JVM libraries, regardless of what language they're written in. But the base JVM types that Java uses heavily are kind of the lingua franca for doing interop between all these different languages. The strings, the primitive numbers, basic object references, interfaces. That's the cleanest way for languages on the JVM to interop, rather than trying to do it at some higher level. And of course, it's very straightforward to use from JRuby. So let's take a look at the very simple example. Just a dumb class has one public field, a private field, some accessors, a method at the bottom, do something that takes an interface, a runnable. So we've got this Java class, and we want to interact with it from Ruby. It's very trivial to do, require in Java support. So we have support for all the JVM types in Java interop. We import that class, which will basically just assign a constant in the current scope, the current context, pointing at that class. And from there on, it pretty much is just Ruby code. Construct a new instance of it, passing in whatever Ruby arguments. We'll figure out how to try and map that to the constructor or give you an error if it doesn't match. Accessors, for example, here, get name, we turn it into more of Ruby accessor styles. So you can do simple.name or simple.get_name or the full-on Java-like get a capital N name. Again, with the set name, we just turn it into sort of a Ruby attribute accessor, and so you just assign it right into the object, and it looks like a regular Ruby call, rather than littering Java-like code all over your Ruby code base. Public fields will also be accessible, and we have some heuristics to manage which public fields are exposed and which methods are exposed. Down at the bottom here, we have do something, and again, with the intent of keeping it feeling like Ruby, whenever there is the camel casing in Java, we'll throw an underscore in there so that you can call it with the normal Ruby-like name, and it keeps the code looking a little bit more clean. More interestingly here, though, is that the fact we're actually just passing a block in to do something. JRuby will, if the last argument to a call is a regular Java interface, accept a block and just make that block magically implement the interface for you. So all of these patterns that are essentially like passing in a closure or a block, that's exactly how you do it in Ruby. A little bit more concrete example, popular Java-based graph database, Neo4j. You can gem install Neo4j and try some of this out. And these examples are actually just lifted right from the gem. High-performance NoSQL graph database being used for a lot of applications, more and more applications these days now that NoSQL is still in vogue. So Neo4j is the gem, and that will pull down the Neo4j jar as well as some wrappers that go around it, which are essentially just written in Ruby using our integration layer. So here's a quick example. We have our little model object, a person. We include the Neo4j node mix-in, so it becomes a node within the Neo4j graph database. We've got a couple properties named here. We have some relationships, so it has n friends for this person. We've got some Lucene indexes, which is just built into Neo4j for doing faster searches across the graph. And then a simple 2s that we define in Ruby just to show off what the person's name actually is. Now, using this, here's a little command line tool. Neo4j will persist back out to the disk every time the process ends, so this will run and repeatedly update the same database. We have a Neo4j transaction.run. We pass that a block. Within there, we can create models, modify models, delete things, do walks over the graph. And when the transaction is completed, it will commit it and push it out to the database that's on disk. Here's one where we're actually going to find what we're doing a query for the person that we want to locate, passing in a key and a value. Person.find, similar to an active record sort of model, will do the lookup and walk the database and find where those persons are. And then, of course, simple things like being able to walk all of the different objects that are in the graph database, all nodes.each, and just walk and check each of them. Interestingly here, Neo4j will pass you the ref node when it's done walking the graph, so you know that you've actually completed the full walk. Okay,
JavaScript.
so off from Java onto JavaScript.
So we couldn't actually find a JavaScript logo.
I don't think there is an official JavaScript logo, is there?
But it's such the rage.
Yes.
People not only use it on the client, they now use it on the server.
Everybody has to have a logo, right?
Right? Node.js. Well, about a year ago, we went and saw a really cool demo of someone who had a very specific server-side need. He had a server, and for the life of me, I can't remember what the service was, but it allowed users to go and upload snippets of JavaScript that ran on a server, but he was really concerned because people would make mistakes and be in some tight while loop and then essentially create a denial of service attack. He was also worried about people, hacking the system, calling outside of that script engine and executing a process. Rhino for the win. Because it runs on Java, you can set up a Java security policy and restrict their ability to go and call out to those various APIs like executing processes. But even more interestingly, Rhino has capabilities for monitoring the execution of JavaScript itself. And we're reusing his demo. We're actually reusing a lot of people's demos today. If you're in the audience, thank you. Super awesome. That requires how you actually load the Maven gem that we were talking about earlier. The top snippet, we're actually using Rhino's Java API to go and set up the runtime instance. We're setting up a context to evaluate things on, and then a basic object scope in JavaScript itself. And down below, we're just executing that string code against that scope. So I didn't know how to actually print out stuff in JavaScript, but then I realized that you can, in fact, go and call Java code. So I'm like, out.println, sweet. And then we were talking about this yesterday, and I'm like, Ruby's calling Java API to set up JavaScript, which is calling Java. Well, what if we actually used embed scripting context? We could call back into Ruby again.
Yes.
Sorry, didn't do it for the demo, but it's just a sweet thought. There was two things that had to be set up. One was a restricted context, which allowed you to go and capture the time that the script started executing, along with how many JavaScript instructions were executed. And then a context factory. And there's really only one method worth looking at here, and it's observe instruction count. Periodically, it'll go and pass in that restricted context and how many instructions had been executed since the last time this method was called. And then you can just see the if statement's very simple. If we haven't executed more than 1,000 statements, or it hasn't been running longer than 5 seconds, you're okay, but if you have, then it raises. And if we run it, it made it through 7 print statements and 1,000 instructions. So I really have no idea the granularity of what instructions are in Rhino, but there must be a lot of them.
So doing 7 iterations it crossed the 1,000 instruction limit in JavaScript. So.
But as far as I know, no other JavaScript implementation has this resource management facility, so it's a pretty cool feature.
Right, exactly. The ability to be able to sandbox a piece of JavaScript code and allow users to submit an arbitrary piece of JavaScript code, all because we're running on the JVM, we have the security policies, and because this implementation is able to watch how much instructions are being executed. So Clojure. Clojure fans in the crowd here? Cool. There's a few of you. All right, so Clojure. This is my description. I think it's a nice short description. It's kind of a Lisp for the JVM that's focused on concurrency, making concurrency easy. So it's immutable by default. You can mutate things, but there's specific ways you have to do it. There are what's called persistent data structures. I'll explain what that is in a moment, as well as software transactional memory, one of the first languages to really popularize software transactional memory, at least on the JVM. And again, if you want to play with Clojure, it's very easy. You can just gem install the Maven library.
It also popularized Lisp on the JVM.
Yes, I don't think it had a whole lot of impact before that. So persistent data structures. Here's kind of the canonical Clojure diagram for persistent data structures. What we have over there on the left side is a large graph of objects. This is essentially a tree in memory that represents, for example, a hash or a list. And what we want to do is we want to add a node somewhere. Now, persistent means that most of the nodes from the previous collection are still carried across and still referenced in the new collection. Only the path you need to modify through that collection is new in the new version of it. So it reduces how much object churn you have. You don't have to recopy the entire tree of objects. And it still preserves all of the same immutable constraints. You always know that the copy of the collection you have in hand is not going to mutate out from underneath you. It's going to look exactly the same as long as you're holding that collection reference.
And all old references are still valid as long as something has it.
Exactly. And all old references stay there. If they happen to fall off, then they just go out and they're normally garbage collected as regular JVM objects. So here's an example of using some of Clojure's. We're kind of cheating with Clojure here. You can go use the language, of course, and it's Lisp, and it has these facilities. But the interesting bits are really the libraries, the built-in stuff that comes along with Clojure, which you can use as just a normal Java library. Here we're importing Clojure lang persistent hash map, which is their version of a map. So we have a little Ruby hash that we'll use to prime it. We construct a new persistent hash map, and we get our Clojure hash out of that. Printed out, pretty much looks the same as any other map. We're going to iterate across all those, and again, it works the same. Selecting, same sort of thing. We're going to turn it into a series of arrays. But then more interestingly, let's actually try and modify this collection. Because this is an immutable collection, and you need to always get a new version of the collection out, you'd get an unsupported operation exception raised. So you cannot mutate this directly. That's part of the guarantee. No one else can mutate it either. You know the collection's always going to look the same. What you actually need to do instead is call the assoc method to do a new association in this map, which returns a new reference to a collection. So over time, you will churn through a couple of these top-level nodes and make some minor modifications. But for large graphs, large maps, and lists, you'll save most of that content across all of those changes while still having all the full immutable semantics preserved. So then there's the STM, software transactional memory. Basically, software transactional memory in Clojure gives you a transactional ref object. That ref points at one object somewhere in memory. In order to modify what it points at, you need to start a transaction using the doSync call. DoSync call wraps that piece of code in a little Clojure, essentially. And then within there, you can modify as many refs as you want, and it will try to commit those changes once the transaction is over. If, during the time that the transaction is running, somebody else manages to commit theirs first, it'll just rerun yours again. So there's a potential for some churn if you have lots of threads contending for the same transactional refs. But in practice, that doesn't happen a whole lot. Usually someone will win, and then someone else will see the new changes, make their own modifications, and proceed from that point. And again, being able to use this all from Ruby, here is basically Ruby code using Clojure's STM. We import Clojure lang ref and locking transaction. We're going to create a new ref that just points at a string to begin with. You can see that you dereference it, and we get the string out. And then we'll try and just set it directly without a transaction. You get an illegal state exception. You can't modify a ref without this doSync transaction wrapping around it. So then what we'll do is we'll take a locking transaction, tell it to run in that transaction another set to the ref. That transaction will actually succeed and be committed to the ref, and then dereferencing it later will actually show the new value. Notice here, this run-in transaction is actually capital I, capital T, run-in transaction Java method on the Clojure library, and we're passing a normal Ruby block to it. It runs the Ruby block in the transaction just as you'd expect it would. So Cloby is a little library that I wrote that kind of combines all of this and makes it just be like normal Ruby. It combines the persistent data structures. It uses one of the persistent list forms. It takes this software transactional memory and plugs it into JRuby as just a transparent part of the Ruby language. And what you actually get out of this is transactional instance variables. So you can extend from a Clojure : object, and all writes that you do to that object have to be done within a transaction. But you're guaranteed that those instance variables will never be mutated without a transactional semantics behind it. Very nice little toy. I don't have, it's on my machine, so we'll switch to the end for the demo if we have a little bit of time to show that. Kind of fun to play with, and I'd like to see more of this kind of stuff done, more experimentation with this on JRuby.
Oh, that wasn't for Scala. That was for Clojure.
Scala fans here? There's a couple.
A few.
Okay.
So I'm not a Scala programmer, but we came up with a term which we think will be our contribution to Scala.
Yes, I think this will take off.
It's an omni-paradigm programming language.
Yes.
It's object-oriented, it's functional, it's got a rich type system, and every other thing that you've ever heard at any computer science class you've ever been to.
Yes, it's all in there. Everything is there.
It's the everything language. What we're going to show a demo of is Mirah, which is a nice Ruby wrapper around Akka, which is a popular actor framework in Scala. And in a sense, we're sort of having our cake and eating it too, because we don't actually have to learn any Scala to make use of this very useful Scala library. The demo that we stole was from Elise, thank you. But it was ported from using Java integration, directly calling Akka's Java library support, and ported to have a nice Ruby syntax. There's 4 actors. There's a conductor that receives a band list, and then it sends start messages to each of the instruments, and then when one of the instruments is done playing, it sends a request back to the conductor saying, "Let me play my end note," and then it says, "Oh, okay," and then it plays it. This is a weird demo. The first thing you do is you actually have to get references to your actors, and I have to ask this question, although it has nothing to do with polyglot programming. How many people like tap?
Okay, good. There are a few people.
There's a few. How many people dislike tap? Okay, a couple. Okay, well, you guys can leave the room now. So I use tap to go and put the start on one line. Deal with it. Okay. So we have a simple struct called band, and then we put the 3 instrument actors into it, and we pass it using the send one way method in Akka. You'll notice that it's less than less than. This is an illustration of having a friendly Ruby syntax. And then we sleep for some amount of time and then ask all the actors to stop acting. In the conductor, it receives two messages. You can see that it extends Mika actor, which is actually an Akka actor, if I'm pronouncing Akka right. But the first one is the roster, in which case we do another send one way to each of the instruments. And then it also receives an AND and then goes, oh, okay, yeah, you can play the AND, and then replies back with AND. The instruments, if they receive a start, they play an MP3 based on their name, guitar.mp3. If it receives an AND, then it's guitar end.mp3. And in fact, drum actually overrides this play method to send the end request. And to totally drive that thing home, and the diagram's wrong, which I realized this morning, but I thought we were going to use Charlie's slides, so I didn't bother to update them. Bass will send an end message back to conductor, and then conductor says yes, and then it plays bass. So if I can have Charlie be the hands here, and then I have an ulterior motive for this. Go into Wonky Music Mika. Just hit return once. It's pretty funny because he doesn't use Emacs, and I'm using shell mode. Okay. So JRuby --1.9 play. And
we'll put the mic down there too. Yeah, it is a terrible conductor. I would not recommend that you use this for your music generation, but
you know, the other thing I really love about this demo is it's really fucking long. It's like 40 seconds.
There, awesome. Oh,
no, it's not done.
Wait for it.
We're halfway done.
Yeah. All right.
Sweet.
So really, the best part about that demo is we could do that as a talk about how concurrency works and how you don't know how things are going to be delivered in order, and it would be exactly the same demo.
So one last point to this demo is this was all using a Ruby syntax, but you could have certainly used the features of Scala and wrote some of your actors in Scala and taken advantage of one of the thousands and thousands of features of Scala. So
there you go. All right, so the last one I'll cover real quick is Mirah. Mirah is another little language that I've worked on some of the time. Nick Howard here has also been taking over a lot of the work and bug fixing lately. And I have to do my fancy animation here. Woo. Yes.
What just happened?
Oh, isn't that magical? We've got to do that one more time. Yes. that was one of my Saturdays.
I think it looks different now.
Was creating my little ambigram there. Okay, so yes, and you know, I'm available for all sorts of other events as well. So Mirah is basically a Ruby-like syntax for creating Java or JVM bytecode. It is not Ruby. That is the common misconception. Mirah does not run Rails. It is essentially just a Ruby syntax for writing JVM bytecode. That's all there is to it. It's very clean and beautiful and simple like Ruby. And what you get out is plain old Java code. It can just generate Java code for you, or JVM bytecode. So if we take a look back at our lovely Java example of a simple class here, this is essentially the equivalent in Mirah. Generates almost identically the same code in either a Java source form or a JVM bytecode form. So it's intended to try and give some of the Ruby feel, at least the superficial Ruby feel, while still having the straight-up static type semantics and raw Java code and raw Java performance that you want when you run on the JVM. So that's the simple example. And interacting with this class would be exactly the same as the Ruby code we saw before. It is just the normal Java class. All of the code that worked before essentially works the exact same way with this. So perhaps playing around with a little bit more, something a little bit more interesting, the final thing here, there is a Java inline gem. It basically is a plugin for the Ruby inline gem that allows JRuby to embed into Ruby code any number of languages, and they just embed as if they're a regular method. So it currently supports Java, Mirah, and Scala. Other languages would not be difficult to add to it. And it is all written in Ruby, so it just calls out to those libraries' compilers, dumps it into the Ruby class, and you've got a method in your Ruby class that is implemented in any one of these languages. The caveat is I don't think anyone actually uses this gem, but maybe it'll be interesting for somebody in the future. So here we have we're starting our new startup that is going to be the fastest factorial and fib generator of anybody. So this is kind of a Wolfram beta that we're going to give out to the world. And so here's the Ruby versions, and we've got our Ruby versions, and we go to market, and it's working great, but it turns out it's not quite fast enough. We're not generating those Fibonacci numbers as fast as we'd really like to. So we thought we'd try a few other languages and throw them in here. So here, we'll just do one in Java. This is pretty much the same Ruby inline syntax. Inline Java, we'll set up a package for the Java code to go into, and then just have raw Java code as a string right there in the code. This actually will then define a factorial Java and a fib Java method on whatever the current class body is. And when you call those, it will just be calling straight out to the Java version. Again, another one in Mirah. The one in Mirah is a little funny because it almost basically looks like Ruby code that's embedded in a string in Ruby code. But it is statically typed, and it becomes essentially what the Java code would do. And then, of course, we have our Scala version, which it's a lovely, beautiful one line of unintelligible code. But there it is. And if you like Scala, you can embed that just as easily. So another simple little way that you can do language integration with JRuby. And I think that's about all we have. We started a little late, so we can delay you all for lunch if there are questions you'd like to hear. We also have in the back, Shane is guarding the JRuby shirt table. So everybody in the room should be able to get one. And then everybody else that's not here, they'll just have to pick up whatever's left. And we have time for questions. So questions about any of this? Yes? For this particular benchmark, they actually end up being basically all exactly the same. Because at the JVM level, it all just compiles down to the same bytecode and optimizes the same way. So, what?
But the Scala one does more. So.
Yes, the Scala one does more. It's magical. Yes?
So I know I'm asking you to predict the future here, so whatever. But I have heard talk they are looking at adding real support for software transactional memory to the JVM rather than just being a language-dependent feature. If that happens, do you think there would be a possibility of seeing real STM in JRuby itself?
So the question is that there's a possibility they might add STM to the JVM itself. Certainly, if anything that they add to the JVM, we'll take advantage of. And things that they have not officially added to the JVM, we even take advantage of. So yes, we would love to see that, and we'd love to have raw VM support. But in the interim, there's things like Clojure and Clobee that can give that same sort of logic to you.
And it will be exposed as a Java API, so we'll be able to use it automatically.
Of course.
By that means.
One more in front here.
The trend of people committing to JRuby, do you see it rising? Is there a lot, or is it plateauing?
Well, actually, so the question was about the trend of committing and contributions to JRuby. It seems to endlessly go up. Actually, I just from commits for the core folks, who there's about a dozen of us, I noticed over time that it's over the past 52-week trend on GitHub, it's still continuing to climb. But we're also getting a ton more pull requests and patches coming in from people, so it's continually growing.
Yeah, I'd say we get a lot more one-off pull requests, and that continues to grow consistently.
We'll take questions till they kick us off. How about you right over here?
In a case like Clojure, which is meant for doing things in parallel, if you have something like you're creating a Clojure to pass to a sequence that you want to iterate over, what happens, how do you support parallelism if your host environment is Ruby and you have these bindings over here and you're trying to send it to something that wouldn't allow that?
Right, so a question about passing, for example, a Ruby Clojure, Ruby block, we'll say, so we don't get the confusion, a Ruby block into Clojure to do some iteration. Anytime Clojure interacts with anything that's not Clojure, you have the potential for concurrency semantics to be broken. So you would have to guard that logic within your Ruby implementation to make sure you're not doing things that would be bad for concurrency. But otherwise, it pretty much just will call functions that you pass in, and so it is pretty easy for you to take a piece of Ruby code and pass it to Clojure and just have it run.
It's pretty much all the same design concerns you'd have with calling Java from Clojure.
And with that, I think we'll close it off. You can come and grab us for other questions. Make sure you get a shirt on the way out, and we'll see you around.